I've used this argument for many years, that in the scientific literature, they refer to a woman, and secular scientists since about 1987 referred to her as Mitochondrial Eve. That's what they called her. And they called this figure, this historical figure, Y-chromosomal Adam. Pretty interesting names for these two figures. And they've argued that these two figures are the ancestor of all living human beings today. Mitochondrial Eve is the mother of all the living. Y-chromosomal Adam is the father of all the living. So if you're trying to figure out what this is saying and how they get to this conclusion, in every cell in your body, you have various different organelles. You got the nucleus, and then you've got the DNA, RNA, the Golgi apparatus, the endoplasmic reticulum, and then you've got these powerhouses. I mean that quite literally. The powerhouse of the cell is the mitochondrion. These are the factories that produce energy. Now, mitochondria, plural, mitochondria contain a very small, unique genome within the mitochondrion. It's only about 16,000 base pairs, but it has its own unique genome. And this genetic material is only inherited from the mother. So it's got a little tiny genome, 16,000 base pairs, compared to the 3.2 billion in the rest of the human genome. And this only comes from the mother. Well, why is this only inherited from the mother? Well, a little bit of sex ed, real quick. The egg that is fertilized by the sperm, the egg contains many, many, many mitochondria. The sperm cell contains virtually none, maybe a little bit. Regardless, when the sperm enters the egg and creates the zygote, the sperm is eliminated, the DNA is passed into the egg, and the zygote is created, and no mitochondrial DNA is transmitted from the father into the zygote, which is the nascent form of a human being, the first seconds of a human being. So this genetic material in the mitochondria only comes from the mother. When we look at and compare the mutation rates of this DNA, mitochondrial DNA, we can say, well, there's a mutation every so many thousands of years, or this many generations. So if we've got a certain set of 16,000 base pairs, and we compare that with other human beings, they can break this up into different groups. They call these haplogroups, where certain groups they can identify came out of Africa. That'd be L1. And then moving north, L2, L3. And they've got these different groups. And there's a little bit of difference and divergence in the mitochondrial DNA. Well, they can look at these mutation rates and start to speculate, or not speculate, that's the wrong word. They can start to project the mutation rate. Well, if it mutates this much in this amount of time, they can extrapolate. That's the word I'm looking for. They can extrapolate that back into the deep past and say, if there's this many mutations in this much time, well, if we multiply the time, we'd have this many mutations, and that would take us back to roughly 150,000 years ago. That's when they would date Mitochondrial Eve. Now, in the last couple decades, there's been an advent of study referred to as ancient DNA. Think Jurassic Park. What they've done is they've found ancient human bones. I mean, we're saying 40,000 years ago. Neanderthal bones. They go back further than that. They went extinct 40,000 years ago. So they go back 60, 70,000 years ago. They've drilled into these bones, these hominin bones, and extracted little chunks of sequencing of the genome. I mean, we're talking like 50, 100 base pairs. David Reich is kind of the leader of this ancient DNA study. Now, they've reconstructed the ancient genome of the human being, and they've reconstructed the ancient genome of Neanderthals. And they've gone over this not once, not twice, in some cases 35 times. It's kind of like smelting gold. You bring it up to a liquid, malleable liquid, you get rid of the dross, and then you let it harden. And then you heat it up again, you get rid of the dross, and you let it harden. That's kind of what that is with these sequencing of the genomes, is that they go over it 2, 3, 10, 30 times. What they found is that they can date the bone, the ancient bone, and they can sequence the ancient DNA of humans. And what they found is, independently, the mitochondrial DNA clock, mutation rate, this much time, goes back to 150,000 years ago, and the ancient DNA of the actual physical concrete bone goes back to the same time period. So this has been locked in. Even the guys at Reasons to Believe, a Christian apologetics ministry, great ministry, they even said this is so serious that we used to say humans appeared on the scene 40, 50,000 years ago. In their recent book, they said we were wrong. We need to reevaluate our view. Adam and Eve need to go back at least to 150,000 years ago. That's their view. With me? All right, that's mitochondrial Eve. What about, this would be the idea. So at the top of the tree, you've got mitochondrial Eve, and then she gives her mitochondrial DNA to any female offspring. Well, she gives it to the male too, but it's effete. It can't get past the male to his offspring. It only goes through the offspring of the woman. So we can track this back to a singular ancestor of the human race. What about Y-chromosomal Adam? Humans have 23 pairs of chromosomes, and the first 22 are what are called autosomal chromosomes. But the 23rd is that very special chromosome. It's your sex chromosome. Either you're an XX or you're an XY. If you're an XX, you're female. If you're an XY chromosome, Y-chromosomal Adam, then you're a man. So this 23rd chromosome pair gives us either the XX or the XY. The Y-chromosomal DNA can only come from your dad. And the Y chromosome is smaller than the X chromosome, so it doesn't recombine with anything. It doesn't go away. This points to a single male ancestor of all humans dating from 100,000 to 200,000 years ago. Again, there's multiple different studies. They come to different dates and different times. It's somewhere in the range of 100 to 200,000 years ago. That if you track the mutation rates on this particular part of the chromosome, the 23rd chromosome, you can get back to a certain amount of time. So, seems like very good evidence. Here's the difficulty with this evidence. Now, if you were to look on my website right now, you'd see this evidence. But I'm starting to doubt whether this is actually useful to use. And I'm going to give you my reasons why. We're looking at mitochondrial Eve, and we're saying she's the ancestor of all living people. Yes, that's true. However, from a neo-Darwinian perspective, they would say that's just the woman who happened to pass on the mitochondrial DNA. So there could be, on a Darwinistic perspective, there could be other humans that were also living at the time. However, here's the key, they don't show up in our genetic signature. So it's 50-50. Mitochondrial Eve could fit with design, creation, or it could also fit with neo-Darwinism, because both hypotheses are equal. Neither are true. So, to put this real succinctly, mitochondrial Eve is not the only one who lived. It's not that humanity went back to one woman. She's the only one whose female offspring lived and reproduced. Let me put it this way. Which one of your ancestors died childless? None. Which one of mitochondrial Eve's offspring were not female who did not reproduce? None. If she's mitochondrial Eve, she had to have had a daughter, a female, and that daughter had to have reproduced. But that doesn't preclude the idea that there could be other humans that also lived but didn't pass on this mitochondrial DNA. Are you with me? Here's another difficulty with this view. Mitochondrial Eve is a different person as you move back in history. So right now, there is a mitochondrial Eve. I don't know what she looked like. I don't know when she lived, but there is a specific woman who existed who is the mother of all the living. However, if we go back 200 generations, 500 generations, 1,000 generations, that mitochondrial Eve would be a different woman. That raises issues. So we're looking at this perspective as though it's just this mitochondrial Eve right now. But if we go into the past, we could actually show, like if we got rid of those generations up front, and I'm not saying that there's only 8 generations or whatever. Hope you can follow the illustration. But if we go back into the past, mitochondrial Eve, as we know her now, actually had ancestors before her that go back all the way to another mitochondrial Eve. So the people living at that time in the past would have a different mitochondrial Eve. So let me see if I can put this all together. This is complex to think about. Is this evidence of Adam and Eve? All right, for one, this doesn't show that mitochondrial Eve and Y-chromosomal Adam lived at the same time or even in the same place. That's a difficulty. Now, they could have. Maybe they did. It just doesn't show that. Number 2, if common descent is true, what I mean by that is, if the great apes and humans had a common ancestor, monkeys didn't evolve into humans, we know that, right? But monkeys and humans, according to neo-Darwinism, had a common ancestor 6 to 10 million years ago. If that common descent of humans and the great apes exists, if that picture of humanity is true, we would still have a mitochondrial Eve and a Y-chromosomal Adam. So again, I just want to point out, this could fit with biblical theism, but it could just as in fact, it has to fit with neo-Darwinism. It has to. 3, mitochondrial Eve and Y-chromosomal Adam are different people as we go back in time. The set of people who are the descendants of mitochondrial Eve change as you move back in time because a different woman or a different age or a different time would actually be the descendant or the ancestor of all the living at that time. What that means is, as you go back into deep time, that these are actually different people. It's not as though there's one woman who existed who is the mother of all the living, unless God just decided to come into the life of mitochondrial Eve and Y-chromosomal Adam at the right time in the right place. But, okay, if you want to hold that view, that's fine, and I agree with you. The problem is these data don't support it. This could fit with a neo-Darwinistic perspective. Finally, this part of the genome, Y-chromosomal DNA and mitochondrial DNA, only accounts for 2% of the genome. And as we're going to see, there's a lot more that we need to wade through in order to understand the genetic inheritance of humans, Homo sapiens, human beings. So this would only account for part of the human story. It wouldn't account for all of it. Now, it plays a very important part. It confirms the out-of-Africa hypothesis. It confirms that it goes back to 150,000 years. That's really good. I just am wary of pressing this argument too much. Great question. Mitochondrial Eve and Y-chromosomal Adam, even the language of leaving the garden, these are all secular terms. I suspect they picked these terms because it would help in the media. The media are willing to sell mitochondrial Eve, but if they sold last living ancestor of mitochondrial DNA, I just don't think that would be as sexy, you know what I mean? But mitochondrial Eve, they really like. Yeah, good question. Part of it is that when humans grow, they grow as populations. They don't grow as individuals. So I get your point that we've got an individual woman at the top, and then she has babies and babies and babies. I mean, on the biblical view, what you're saying is absolutely true. The difficulty is that we're trying to leverage this argument to say that, no, it's not just a biblical view. It's true in the natural sciences. Now, a natural scientist would say, well, no, it ain't. And we would say, yes, it is. And they'd say, no, humans came from a population of 10,000 people. They didn't come from a single person. In other words, Homo sapiens evolved not as one Homo sapien to another in a linear fashion. They evolve as a group. The group evolves. So if we're trying to use this argument with a secular scientist, they're going to say, no, the group is evolving. You can't just say it starts with one woman. That's assuming what you're trying to prove, that there is one singular woman from whom the entire human race began. So it's hard to wrap your mind around, but I guess I would just say if we're trying to use this to persuade a secular scientist and we say, well, it started with one woman, they would say, no, it didn't start with one woman. It started with a population. We just have a marker of one woman. But then when there's genocide and war and infertility, and then it's going to change to another person because there's a group, not just an individual. That's really good. That's probably better than what I've been doing for the past 20 minutes. If you start with all these different women, eventually you'd say, oh, well, they're all, lots of mitochondrial DNA, but then woman 1, 2, 3, 4, 6, 7, 8, 9, 10, 10,001, 10,002, their lineages die out, but that one remains. But really, it would be half of them remain for a while, and then a quarter of the total remain for a while, and then a quarter of that, eventually would die out into separate groups.